Welcome to Algebra 1, Semester 1, Unit 4-5, Section 7.1. Okay. How do you write equations of parallel and perpendicular lines? Well, it has to do with the slope. If we think about two lines and they're parallel, like these two pins are parallel, if one turns this way, it's no longer parallel unless the other one turns with it. So their slope in parallel has to be the same. Now, if you think back to our last lesson, their slopes would be the same, but their y-intercepts could not be. If their y-intercept was the same, then they would be the same line. For example, there's a line with that slope. If it has the exact same y-intercept and it's got the same slope, it would just lay right on top of that line. So, in your y-axis, y equals mx plus b form, you have the m's, which would be equal, but your b's could not be equal for parallel lines, and that's parallel. Okay, now if we look at a line that's perpendicular, let's say that we have a slope of -1/2. So it rises 1 and runs 2. That would be the slope. A perpendicular line will come in and form a right angle with that. And what's really unique about the perpendicular line is see how it has a negative slope? It goes up to the left. Well, this is true of their slopes, is that they will be opposite, and the other unique thing is that they'll be reciprocals. So when I multiply these, the product always equals -1. So perpendicular lines, their slope m1 times m2 equals -1. Okay? So now let's spot these. If the slopes are the same, they'll be parallel. If they're opposite reciprocals, they'll be perpendicular. So 2/3 and 2/3 is our slope. Those would be parallel, because 2/3 is equal to 2/3. Okay, -4 is over 1. -4 and -1/4 might tempt you to think that they're perpendicular because they are reciprocals, but they are not opposites. So if we think about drawing those two lines, -1/4 goes like this, and -4/1 goes like that. They're both going up to the left. So those two lines are neither parallel or perpendicular. 1 and -1, well, that one is kind of hard to see as perpendicular because you don't notice that they're opposite reciprocals. But in fact, you could use the rule that I gave you, that the product of two perpendicular slopes will be equal to -1. The product of 1 and -1 is in fact -1. So those are perpendicular. Okay. Can you decide if lines are parallel, perpendicular, or neither when given the equations? Well, now we need to spot where the slope is. Remember, our equations are in the format y equals mx plus b. Which of those was the slope? If you said m was, you're correct. It's attached to the x. So, underline your slope, pull them out, 2 and -1/2. If I was to multiply those, put a 1 underneath that 2, they would equal -1, so those two are perpendicular. Okay, the next one. 4x plus y equals 8, and y equals negative 4x plus 2. Well, we need to get the y alone here to get it in slope-intercept form. So we subtract 4x from each side, and we get y equals negative 4x plus 8. Now these two do appear to be parallel. And the way that I know that is that their slope, negative 4, is equal to negative 4. You do need to show that. The next line is a positive 3 and a negative 3. If you said those are neither, you are correct. They are opposites, but they are not reciprocals of each other, so they are not perpendicular. They're not identical, so they're not parallel. Can you write an equation of a line that is parallel to the given line passing through the given point? Well, all that we need to remember is point slope form. Y minus y1 equals m times x minus x1. Okay? So if we can find the slope and put the point in, then we have an equation for the line. Here's the point. This will be our x1 and y1. And we look at this equation, we say, where is the slope? If you said 6 is our slope, you're correct. It's that m value. So now we write our formula. Y minus 3 equals 6 times x minus 5. You do not need to put it into slope-intercept form. It does not ask for that. On this one, we have to get the y alone in order to find the slope, so we subtract 3x from each side. Negative 5y equals negative 3x minus 25. Divide by negative 5. Y equals 3/5 x plus 5. Okay. Now we have the slope. There's our m value. Here's our x1, y1. So we're ready to write our equation. I'll slip it over here, a little bit further over. Y minus negative 8 equals our slope value, 3/5 x minus 10. Now the only thing that I would ask you to do in finishing that off on a test is to clean up the negative negative and make that a plus. Okay, very good. Write an equation of a line that is perpendicular to the given line passing through the given point. Well, this time we take the slope and we find the opposite reciprocal. So 1/5 would become 5/1, and then we bring in the negative sign. So that's our slope. Our point is still x1, y1. So we have y minus 7 equals negative 5, you don't have to put over 1, times x minus 3. Now if you did put over 1, that's fine. It doesn't really matter. Negative 5 is equal to negative 5/1. Next one, we have a slope of 2. That would be 2/1. To find the opposite reciprocal, we flip it and we change the sign. So there's our m value for the perpendicular line. Here's x1, y1. We have y minus 2 equals our m value, negative 1/2, times x minus a negative 6, which we would clean up and make it into a plus 6. Okay? And the last thing that I want to give you is that formula one more time. This is point slope. Point slope formula. Okay? y minus y1 equals m times x minus x1. Okay? We're going to skip over this next page. Go ahead and turn past it. We'll come back to these on the next lesson. I just want to get to page number 5 because we'll be doing a lot of these in class. It's a linear system. Anytime you have 2 or more lines on one graph, it is called a system. And anytime those lines are straight, that's a linear system. So pause the video and explain that right there in words. 2 or more straight lines on one graph is a linear system. Pause the video and write that. The next question asks, how do you approximate the solution of a system of linear equations by graphing? The solution of a system is the point at which the lines cross. It's the intersecting point. So that's how you approximate it, is you see about where they cross. So fill that in. And now let's move it down to the actual doing of these problems. A system of 2 linear equations has infinitely many solutions. What must be true about these equations? Well, let's picture these. If we were on a graph and we had perpendicular lines, well, right there's perpendicular lines. If they laid right on our x and y axis, they cross and there's only one solution. So that's not infinitely many. I would eliminate that one. In math, when you do multiple choice on any of these standardized tests, your best approach is to eliminate what you know is not correct, what you can reason to not be correct. Okay. They are the same line. Well, let's see. If we were to draw a line, and then we drew another line right over top of it, those are the same line. Do they have infinitely many solutions? We go back up here, what I said solutions were, I said it's the point at which they intersect or cross. Look at all the points these intersect or cross. And you know that there would be more points in between the points that I drew. So that would be correct. They are the same line if they have infinitely many solutions. Which of the following equations have no solutions? Well, when would we have no solutions? We see one solution here. We see infinite solutions. Let's think through, when would they be no solution? Well, that would be when they never crossed. I guess that's when they'd have to be parallel. Parallel lines would have no solutions. What do we know about parallel lines? Well, in our last lesson, we discussed parallel lines have the same slope, but that their y-intercept cannot be the same. So we need to get these in slope-intercept form. That means getting the y by itself. Subtract 6x from each side of the equation. We get 2y equals negative 6x plus 8. Now we divide by 2, and we get y equals negative 3x plus 4. Okay, so our slope needs to be negative 3, but our y-intercept cannot be 4. So we see over here at our options, we do have, try to get both of them on the screen, we do have that exact line. That would be infinitely many solutions. This one does not have the same slope, so we can eliminate that one. This one does not have the same slope, so eliminate it. This one does have the same slope, and it does have a different y-intercept, so that is our answer right there. Choice C. Can you solve the system by graphing? Well, looking at this graph that's already done for me, I can tell you what the solution is. Solution of this system, remember it's always a point where they intersect, it would be -1, 2, 3, 4 for the x value. And now we count down. 1, 2, 3, 4, 5. So it's approximately -4, -5. When your lines don't match exactly on the grid lines behind, go with the closest grid line intersection that you can. Okay, next one. We're asked to graph these points now. And I hope that I have my straight edge here. There it is. To graph these lines, I would go to the y-intercept of 6. 1, 2, 3, 4, 5, 6. My slope is -1/1. Never ever fall. Remember, I always teach you guys to rise, and then if it's negative, run to the left. So we rise 1, and we run 1 to the left. So there's the 2 points for this line. Okay, our next line, the y-intercept is not given, so we know that it would be a 0. That means it crosses right here at 0. And it has a slope of 2/1. So from that point we rise 2 and we run 1 to the right because it's positive. And I actually just plotted the intersection. So the solution or intersection is 2, 4. Okay. That's page 5. Moving on with page 5. We are asked to graph a few more. Remember, the most important thing here is to get your y alone. So we subtract 6x from each side on this one. 2y equals -6x plus 6. Now we divide by 2 to get the y alone. We get y is equal to -6 divided by 2 would be -3x. 2 goes into 6 3 times. So now we can graph these two. Go ahead and turn off the video, pause it, and graph those, and then turn it back on and see if you have what I have. You rise 1, 2, 3, but this time you go 1 to the left because it's negative. So 1, 2, 3, and 1 to the left. There's the top line. The bottom line has a y-intercept of -4, and it too rises 3 and 1 to the left. We drew those right. They should look parallel. There's no solution. Now, how did I know that they were parallel with no solution? Because I noticed that this slope and this slope were the same, and I noticed that the y-intercepts were different. Okay, so I knew that they were parallel. Okay, on this line, we get the y by itself. We'll subtract 2x from each side. So we have -y equals -2x minus 2. Now we divide or multiply by a negative to get the y by itself, so y equals 2x plus 2. Now we graph that. The y-intercept is +2. and the slope is 2 over 1. So from that point we rise 2 and run 1 to the right because it's positive. And now if we look, the other line is exactly the same. So all we need to do is put 2 arrow tips to show that it's the same line, and we write infinite the many solutions. Okay? I like to do the first part of section 7.6 right here too. It's graphing inequality systems. The only difference with inequalities is that we have a greater than or less than sign, and you simply show that when you draw the line by putting a dash line. Or if we have greater than or equal to, or less than or equal to, you show a solid line. The other thing is that we will shade, and I'll show you how that happens. So the first line that we're graphing is a negative x and a negative 2. That negative x would become negative 1 over 1 for your slope, and your y-intercept is still negative 2. So we go to negative 2. From there we rise 1 and run to the left 1. We go ahead and we put dashed lines. Now, to figure out which way to shade on this, I choose a common point that's easy to plug in, and I like using 0, 0 if it's not on the line. When I plug in 0 and 0 up there into the equation, I have 0 is greater than 0 minus 2. So basically I have 0 is greater than negative 2. Is that true? Is 0 greater than negative 2? The answer is yes. So we shade towards that 0, 0 point. We cover it with shading because it's part of the solution. Now the next line has a y-intercept of plus 1. It has a slope of 3 over 1. So from that point we're going to rise 1, 2, 3, and go to the right 1 because it's positive. This time, we should draw a solid line because it's got the less than or equal to symbol. So this time it's a solid line. And which way do we shade? Well, we just barely missed this 0, 0 mark. We're going to use it since it's this side of that line. So we plug in 0, plug in 0. 3 times 0 will wipe out, and we'll just have 0 there. So is 0 less than or equal to 1? The answer is yes, it is. So we show with arrows which way we shade. Now looking at your arrows, you should be able to detect this section up above the line here and down below that line is going to be doubly shaded. So we just darken that part in. Okay. Next graph. Again, we need to get the y by itself. So we have negative 4y is greater than negative x minus 8. We just subtracted x from each side to get it away from the y. Now we divide by negative 4, divide by negative 4, divide by negative 4. So now we have y, and when we divide both sides by a negative number, we flip the inequality. A negative 1 is actually in front of that x, so negative 1 over negative 4 would be a positive 1/4 x. Negative 8 divided by negative 4 is a positive 2. So our y-intercept is at positive 2. Our slope is rise 1, run 4. We're going to do a dashed line because it does not have that equal symbol underneath the inequality. Now we ask ourselves, will 0, 0 be true? 0 for y, 0 for x would be 0 times 1/4 is 0 plus 2. Is it true that 0 is less than 2? And if you get confused on less than or greater than, remember less than always fits in your left hand. Okay. 0 is less than 2, so we do shade towards the 0, 0 point right there at the origin. Next one, y is greater than 2. We have no slope, so we know that that simply cuts through the y-axis. It is a dashed line. Greater than 2. Is 0 greater than 2? No, so we do not shade towards the origin. Instead, we shade this way. And the only area that's going to be doubly shaded is this little section right in there. So shade that a little bit darker. Okay. Can you describe some disadvantages to solving systems with graphing? That is something that I'd like to discuss tomorrow in class, so please answer that and bring it with you to class. We'll talk about it when we start. We'll see you tomorrow in class. Have a good night.